Okay, hopefully that you can hear me. Okay, so this is module 11. So in this module 11, you learn about interrupt. Okay, there are two types of interrupt. One is interrupt and the other one is polling. So we're going to see what are the difference between interrupt and polling. And then after that, we are going to see the interrupt units. Okay, how to enable interrupt, what are the register that you're going to know in order to initialize your interrupt. Okay, and then you going to the step to execute the interrupt. Okay, and how to enable and disable. Okay, and then as I mentioned earlier, we have two types of interrupt. One is a timer interrupt, the other one is external hardware interrupt. Okay, at the end here, you will learn about the interrupt priority and interrupt inside it. Interrupt, is it working or not? You can do interrupt, another interrupt after you execute the first interrupt. Okay, so let's look at the introduction of the interrupts. So a single microprocessor can serve several devices or tasks at the same time. So this case here, we call it as a multitasking, in which you can do many tasks, okay, at the same time. Okay, so there are two methods by which device receive service from the micro-pif. Either is by using the interrupts or either is by using the polling. Okay, for the interrupt, whenever any device needs the micro-pif service, okay, the device notifies by sending an interrupt signal. Okay, so upon receiving an interrupt signal, micro-pif stop whatever it's doing and serve to the device and a program associated with the interrupt called interrupt service routine ISR or interrupt handler. Okay, so this interrupt here, okay, this interrupt occurs when you're going to do a certain thing. Okay, for example, you are currently now doing a program A. Okay, at the middle of the program A, okay, you trying to interrupt the program A so that you going to execute another program called a program B. So what happened here is a program B will stop, okay, and then the CPU will go to your program B, execute that program B. After that, after the program B is finished, then it will resume back doing program A. Okay, so that is for the interrupt. While for the polling, okay, the micro-pif continuously monitor the status of given device. Okay, when the status is met, it performs the service. After that, it moves on to the monitor the next device until each of one is services. Okay, so this polling here, so again, you currently execute a program A. So in the middle of the program A, you're going to do a program B. But because this is a polling, okay, you use a polling method, what happens is you need to finish the program A, and then after that, after the program A is finished, then you can do the program B. So that is the difference between interrupt and polling. Okay, the interrupt, you can do it immediately when you invoke the interrupt, but for the polling, you need to make sure that the current program that executed is finished, and then after that, you do the next program. So this is the advantage and disadvantage by using the interrupt and first polling. Okay, so interrupt efficient use of CPU. Okay, you can use the CPU efficiently, okay, without wasting any CPU time, okay, and then this one here not an efficient use of CPU. Okay, why? Because this one here you need to wait for the first program to finish, and then after the program, then you can do the next program. But for the interrupt, you can do two programs at the same time. Okay, so this one here can serve many devices, which each device get attention of the CPU based on the priority assigned to it. But for the polling, cannot assign priority. It checks all the device in round robin fashion. Okay, and then for the interrupt versus polling, the CPU can ignore or mask a device request for service. Means that, okay, if that interrupt is not very important, okay, the CPU can ignore that interrupt to occurs. Okay, but for the polling, cannot ignore the device request. Means that if the device requests to do a certain program or to execute a certain program, then the CPU need to entertain to that program. Of course, like it need to finish the program that is currently serve. Okay, and last but not least, this one here, avoid tying down the CPU. Those the waste time can be used to perform some useful tasks, but for the poly, you waste much CPU time by poly device that not need service. Okay, so in order to use the interrupt, okay, we need to have the subroutine called interrupt service routine. Okay, for every interrupt, there must be an ISR. Okay, so ISR stands for interrupt service routine, which is a subroutine for your interrupt. Since when an interrupt is invoked, micro-pif run the ISR. So every time you invoke the interrupt, the micro-pif will go to this interrupt service routine. Okay, so generally for every ISR, there is a fixed location in memory that hold the address of each ISR. So this group of memory locations set aside to hold the addresses of ISRs called interrupt vector table. So this interrupt vector table will determine which interrupt has higher priority. Okay, which interrupt has lower priority. So this is the interrupt vector table. Okay, as you can see, okay, the top here, okay, this one here, this is the highest priority. Okay, while the lower, the bottom here, this is the lowest priority. Okay, if you can see, the reset has the highest priority because the location of the reset is at 0000, and then you have the external interrupt request, which is INT0, INT1, and INT2. So this is another higher interrupt priority. And then you have the timer interrupt. Okay, so this is the timer interrupt. Okay, starting from here to address 0016. And then you have the SPI transfer, USAT, ADC conversion, EEPROM, analog to site store. Okay, so in this, what we call, in this module here, okay, in this topic, we are going to focus on this external interrupt request as well as the timer interrupt. Okay, before we go more detail on the interrupt, how to execute the interrupt, so we need to recap lah our flash memory, okay, which is our program memory. Okay, as we know that there are 32 kilobyte of program memory in Atmega 32, which is organized by 60K, which is a 2-byte word. So you know that the size of this, what we call it, memory is 16-bit. Okay, usually we have a 8-bit memory, but for the program memory, okay, it is a 16-bit wide. Okay, so each word in the memory has a unique address, okay, starting from 0000 until 3FFF. So total up here is 32 kilobyte of program memory. Okay, if you can see here, some of this memory is reserved or protected. Okay, so this, the first 42 word is reserved for the interrupt vector table. Okay, so this one, yeah. And the last 1 kilobyte here, okay, is protected for boot, flash, and section. And then anything in between, okay, anything in between here, you can write down you can store your program. So every program that you written will be stored inside of this application flash section. Okay, so now you're going to see how to execute an interrupt. What happens when you execute an interrupt? So upon activation of interrupt, the micro-pif goes through the following step. Okay, there are 4 steps that you need to remember. Okay, first, it finishes the instruction it currently executing and save the address of the next instruction onto the stack. Okay, so this is what happened. Once the interrupt is invoked, what happened is the address of the next instruction, okay, will be stored to your stack. Okay, so because nanti after you finish the interrupt, then you need to resume back to that program, okay, to that instruction. So that's why we need to store the next instruction of our current program to the stack, and then jump to the fixed location in the memory called interrupt vector table, and then it will go to interrupt vector table, and then the interrupt vector table directs the micro-pif to the address of ISR. Okay, based on the ISR, which ISR that you invoke, okay, and it will jump to this location here. One is jump to this location. Step number 3, micro-pif start execute the ISR until reach the last instruction of the subroutine. Okay, the last of the instruction of the subroutine, if you use the what we call here the assembly language, is labeled by RETI. Means that you know that that is the you're going to return from interrupt. Okay, so upon executing the RETI, okay, the micro-pif return to the place where it was interrupted, and then it will resume back the program. Okay, so the get the PC address from the stack. So this is how the micro-pif continue, okay, return to the place where you invoke the interrupt by putting the address that you already stored to, from the stack to your program counter. Okay, so let's look at this animation here. Okay, so this is the program written in the assembly language. Okay, actually in for the interrupt programming, we're going to write in the C programming. Okay, but we just for this reason, we're just going to see how the interrupts works. Okay, so this is your main program. Okay, you can see here, this is all org0 means that this is for the reset. org0x02, so this one here, you see this is belong to external interrupt 0, which is int0, and then you see this phone line here, this is how you're going to initialize your what we call here step pointer. Okay, why we need to initialize the step pointer? Because you're going to, before you're going to the interrupt, you're going to save the next address to your stack. Okay, so that's why we need to initialize the step pointer, and then this is how you're going to initialize your SBID DRC tree. So this is how you're going to initialize your INT0, what we call it, INT0 switch, so that it become an input. Okay, so every time you press a switch, the interrupt will happen. Okay, and then you enable this one here, you're going to enable the pull-up resistor, and this is the interrupt settings. Okay, what interrupt that you're going to use, and then how to enable the interrupt, all those things here. Okay, and this is the normal punya programming. Okay, and this is the interrupt service routine. Okay, so let's look at this one here. Okay, we just run this one. Okay, and we'll go to main program. Okay, and then up until here, and then your step pointer, okay, will be initialized to here. Okay, so this one here, you initialize your step, your interrupt, all those things. Okay, here, okay, when this one is executed, suddenly, okay, you press the switch at this PD2. Okay, so this PD2, actually another features for the PD2, instead of using it as a input output, you can use it as a interrupt. Okay, to invoke the interrupt, which is INT0. Okay, so what happens when you press the switch? Okay, so when you press the switch, okay, this is all active low. So this address here will be stored to your stack. Okay, and then, okay, your program counter will go to address 002, and then this one here is saying that go to ISRss subroutine. So that's why it go to here and do this thing here. Okay, do all this instruction. One, the micro-pif execute the RETI. So what happened here is you need to take the value from this stack, put it to the program counter, so that after that you will return to execute this instruction, which is ADD-R0, R31. Okay, so let's see here. Okay, when the RET, so you put that value to your stack, the program counter, and it will return to this instruction. These are how the interrupt works. Okay, starting from you invoke the interrupt, put the next address to the stacks, and then after that you go to that interrupt, service routine, which is here, and you do all the program you write in this ISR, and then whenever the RETI instruction is executed, so you need to get back the value, okay, the address that you store in the stack, put it to the program counter, next, then you will return to, okay, to the place that you stopped earlier. Okay, so there are many sources of interrupt in the AVR. Okay, so at least 2 interrupts set aside for each of the timers. Okay, the first one here, we call it as a timer. So for the timer, you can divide it into 2 types. Okay, one is overflow, the other one is... Okay, for timer ada 2. Satu we call it as a overflow, satu lagi we call it as a... Okay, the second one is a CTC or compare mesh. Okay, so this is for the timer interrupt. Okay, then we have a second interrupt. Okay, we only focus on this interrupt and this interrupt only. Okay, the rest will just ignore. Okay, for the external hardware interrupt, you have three interrupt, which is INT0, INT1, INT2. Okay, so to input, to trigger this interrupt, you need to put this interrupt here to a switch. Okay, so where you're going to put that switch? Okay, for INT0, you need to put your switch at the port D, pin number 2. Okay, for the INT1, you need to put your switch at PD3, port D, pin number 3. For INT2, you need to put your switch at PB2, port B, pin number 2. Okay, if you put the switch to others than this location here, or pin here, so you cannot trigger your interrupt. Okay, so make sure that your switch is, you put your switch at this location. Okay, so as I mentioned earlier, so this is your port D. Okay, so port D, instead of using as an input-output port, it also has an alternate function. So now we only focus on these 2 here. Okay, PD2 and PD3, which is PD2, okay, for interrupt, external interrupt 0 input, and PD1 for the INT1. Okay, so this is INT1 and this is INT2. Okay, so we only focus on these 2 here. Okay, so this is your recap again. This is your ATmega32. Okay, so for the ATmega32, you have 40 pin out and you have 4 input output ports. Okay, which is started from port A, port B, port C, and port D. Okay, for the port A, another function that instead of you using it as an input output, you can use it as an ADC, analog to digital converter. While for the port D here, you have another special function that you can use, but we only focus on this pin here, dekat sini. Right, kat sini. This pin here. Okay, PD2 and the PD3. PD2, okay, you need to make sure that you sambung ke switch lah, which is an active low switch. Okay, whenever, because this is an interrupt, okay, it will be activated when it receive a logic 0. Okay, so it is active low. Okay, whenever you press the switch and it gives 0, then the interrupt will be triggered. Okay, so PD2 and PD3 for interrupt 0 and interrupt 1. And the other one here, you need to put here, dekat sini, for INT2. Okay, so this is the switch that you need to connect. Okay, in order to use the interrupt. Okay, up until here, ada soalan tak before we go to how to write the interrupt using the C program? Ada soalan? Any question? Okay, if no question, then we go to how to write the interrupt in C by using the C program. So in C language, there is no instruction to manage the interrupt. Those, okay, you need to add the following in your program, in your WinAVR or in your program in order to manage the interrupt. Okay, the first one here, okay, make sure that you include the interrupt header file. Okay, so make sure that you include this file here. Hashtag include avr/interrupt.cache. Okay, dia punya slash ni terbalik ya. Okay, make sure you correct this slash here. Okay. Okay, once you are include this file, okay, the second thing that you're going to do is you need to enable your interrupt. Okay, so there are two locations that you're going to enable your interrupt. Okay, the first one here either at the GICR or TIM-SKEE register. Okay, for the GICR, if you're going to use the INT0, INT1, and INT2, which is the external hardware interrupt. So you need to enable at GICR. Okay, if you're going to use the timer interrupt, so you need to enable the TIM-SKEE. Okay, so this is for timer interrupt. Okay, that is the first location. And the second location, okay, in order to enable the interrupt, you need to put this one here, SEI. Okay, SEI means that you enable your interrupt globally by put one, okay, to your I bit in status register. Ingat lagi tak you punya status register? So this is your status register. The status register have many flag, which is you have a V flag, I flag, C flag, N flag, Z flag, H flag, and etc. Okay, so make sure that you put one to your I flag kat sini. Okay, when you put one here, so then you already enable your interrupt. Okay, and then once you finish enable the interrupt, okay, so you have two locations, one dekat GICR, okay, to at your interrupt register, and the second one dekat status register. Okay, once you enable at these two locations, then you can do your ISR, your interrupt service routine. Okay, so you write down lah anything that you're going to do. Okay, the program that you're going to do whenever you do the interrupt. So this is your interrupt service routine. ISR followed by interrupt vector name. Okay, so for this interrupt vector name, okay, yang ni, okay, make sure that, okay, you must follow the exact name, okay, as in the table in the next slide. Okay, so make sure that, okay, the name is correct lah. Okay, if you're going to use the external interrupt hardware, so make sure that the name is correct. Okay, kalau yang ni small letter, okay, make sure that you put a small letter, and this one is capital letter, you put it in capital letter. Okay, don't put something like this, INT0, and then vector. This is wrong. Okay, make sure that you follow the name that are provided in this table here. Okay, no need to memorize because this table here will be given in your final exam or in your test. Okay, so jangan tak perlu memorize. Okay, it will be given to you. Okay, if you're going to use the timer interrupt, so this is the name lah. Okay, the ISR name that you need to put. Okay, any question up until here? Okay, if no question, so now we're going to see how to enable and disable an interrupt. Okay, so tadi kita dah tengok. Okay, the second step that you're going to do in order to use the interrupt is enable the interrupt. Okay, there are two locations that you're going to enable interrupt. One dekat status register, the other one at your interrupt register. Okay, so now we are looking at the status register. Okay, after that, we're going to see how to enable at the interrupt register. Okay, so upon a reset, okay, every time you reset your microprocessor, every time you switch on your microprocessor, all the interrupts are disabled. Why? Because all the value inside of this status register is cleared. Okay, that is every time you reset or every time you switch on your micro-pif. Okay, so those, in order to use the interrupt, okay, you need to make sure that this I, bit I here, okay, which is a global interrupt, okay, you need to put 1 lah in order to enable the interrupt. So how to do that? Okay, so to do that, okay, because this, what we call here, this, okay, so this is your status register, bit I at your bit 7 in your status register. In order to enable it, okay, you can write down SEI. Okay, just write down this instruction only. Okay, SEI followed by bracket. Okay, so every time you execute this line here, so I will automatically set to 1. Okay, macam mana nak disable? How to disable? Just write down CLI, means that you're going to clear your status, your I flag inside of your status register. Okay, so this is in the status register. But you have a second location that you're going to enable, which is the TIMSK and GICR. Okay, so let's look at the TIMSK. Okay, if you're going to use the timer interrupt, so we need to enable at TIMSK register. If you're going to use the external hardware interrupt, which is by using the switches, okay, we need to enable the GICR. Okay, so this TIMSK, so this is your TIMSK. Again, no need to remember because this figure here will be given to you. Okay, because we are very generous. Okay, so it will be given. No need to remember. Okay, so TIMSK is stand for timer interrupt mask register. Okay, so you can see this is OC bit. Okay, you have 8 bit wide starting from bit 0 to bit 7. Okay, and then you see here, okay, for the timer, okay, in the lab 2, for the micro-pif, you already, what we call, write a delay for using a timer 0, betul tak? Okay, for the timer, we have 3 timers, which is timer 0, timer 1, and timer 2. Okay, each of these timer here will have 2 type of timer. One is the overflow method, by using the overflow method. Okay, so timer. Kamu ada 3 timer, which is timer 0, 1, and 2. Okay, each of these timer here, you can divide it into 2 types. Okay, one is an overflow method, and the second one is a CTC method. Okay, later in the next module, we will look more detail on how this overflow and CTC method works. Okay, macam mana nak do a timer. Okay, to create a timer delay by using the overflow method and CTC method. Okay, so this is for the timer 0. Okay, if you see here, this is for the timer 0. Okay, so this is for timer 0. Okay, and then if you see the C here, and this is a timer T. Okay, so this is an overflow, and this is a C for compare mesh. Okay, for the timer 1. Okay, you have this one. This is for the timer 1. Okay, for timer 1. Okay, I just timer 0 and timer 2. Okay, this is a 8-bit timer. But timer 1, this is a 16-bit timer. Okay, so this belongs to timer 1. Okay, so again, you have a CTC overflow method and CTC method, and the last here, 2 here is for the timer 2. Okay, so how to enable? To enable this timer, to this interrupt timer, okay, depending on the interrupt timer that you're going to use, okay, to enable, you just put 1 dekat sini. Okay, you just give set, and then what happen if you put all this one here is 1, so means that you're going to use the timer 1, timer 0, timer 2 with the CTC and overflow method at the same time. Okay, so this is how you're going to enable. Okay, to disable, just put 0 je lah. Okay, inside of this register. Okay, so now next we have another register, okay, called a GICR, which is a General Input Control Register. Okay, so this one here use if you're going to use the hardware interrupt. Okay, external hardware interrupt means that the interrupt will external. Okay, the interrupt will be triggered whenever you press switches. Okay, so interrupt will only be triggered whenever you press your switch. Okay, so you have 3 external hardware interrupt, which is INT0, INT1, and INT2. Okay, so this is INT1, this is for the INT0, and this is for INT2. Okay, so make sure that the location is correct lah. Okay, if you're going to enable INT2, so just put 1 here, and the rest you put 0. What about the rest of this bit here? Okay, from bit 4 to bit 0, what value that you're going to put? Okay, just give 0. Okay, because we are going to focus dekat sini je. Okay, at this 3 bits here. Okay, bit 7, bit 6, and bit 5. Okay, the rest you just put 0. Okay, so any question? Okay, so this is how you're going to enable the interrupt. Okay, let's say lah. Okay, you're going to use the 2 interrupt. Okay, INT2 and INT1. Okay, so how to enable? Just put 1 dekat sini. INT1 you put 1, INT2 you put 1 as well, and the rest you put 0. Okay, so later how to put this number to your register here? Okay, by using programming lah, of course. Okay, because we are using the C programming, so next we are going to see how to write this value in order to enable INT1 and INT2 to GICR. Okay, so now we're going to see how to do the external interrupt programming. Okay, we go one by one. Okay, we do the external interrupt programming, and then after that we do the timer interrupt programming. Okay, for the external interrupt programming, recap. Okay, so again, kita dah tengok tadi, we have 3 type of external hardware interrupt. Okay, which is INT2, INT0. Okay, this one here is located at the PD2. You have an INT1 located at the port D pin number 3, and this one here, please correct. Okay, this is an INT2 that are located at port B pin number 2. Okay, so make sure that the pin is correct lah. Okay, whenever you're going to use the external hardware interrupt. Okay, so the hardware interrupt must be enabled before they can take effects. Okay, so again, okay, recall back, okay, to write an interrupt. Okay, you have 2 steps here, 3 steps. First step, you need to include AVR/interrupt.h file. Okay, then after that, okay, step number 2, okay, next what you're going to do is you need to enable interrupt. There are 2 locations that you're going to enable the interrupt, okay, which is dekat GICR for external hardware interrupt and dekat status register. Okay, for the status register, you can use the SKEE instruction. Okay, for the GICR, then we need to program it accordingly lah, according to what interrupt that you're going to use. So this is your GICR. Okay, so make sure that okay the interrupt that you're going to use is correct lah, according to this GICR register. Okay, so for example here, okay, you're going to enable INT0. So how to enable INT0? So this is your GICR. Okay, so 1, 2, 3. Okay, so this is INT1, INT0, and INT2. Okay, so how to enable the INT0? So you are going to use the INT0 only. So macam mana nak enable? So you need to put 1 dekat sini, the rest you put 0. Okay, so to write down in C programming, just write down GICR equal to 0B. Okay, I always use the 0B. Okay, because I'm not going to change to the hexadecimal. Okay, sometimes when you change to the hexadecimal, then you get mixed up. Okay, then the value will be wrong. Okay, so better use the binary number. So I just put 0B 0 1 0 0 0 0 0 0. Okay, ataupun okay, you can write that in using the hexadecimal, of course lah, 0x40, or you can use the binary number. Decimal number. What is the decimal number for 40? Anyone can help me? 1, 2, 4, 8, 16, 32, 64. Okay, too slow. Okay, 64. Semuanya sama, which is you're going to enable INT0. Enable. Okay, let's say like you're going to enable INT1. You're going to use the INT1 and INT0. So what value? How to do the programming? Okay, so INT1, INT0. Okay, the rest you put 0. Okay, so just write down GICR equal to 0B11 0 0 0 0 0 0. So after you write down this one here, INT0, INT1, enable. Okay, if you're going to enable all the interrupt, all the external hardware interrupt, just put 1 lah dekat sini. Okay, put another 1. So this one here, you put 1. Okay, then you enable all the interrupt. So this is how to write, to program in C by using the C program, okay, to enable the external hardware interrupt. Okay, once you did the you enable the what we call here the external hardware interrupt. Okay, then you put the SEI lah down here, SEI bracket and semicolon. Okay, so let's look at the examples here. Okay, assume that. Okay, you're going to assume. Sekejap ya. Okay, assume that the INT0 pin is connected to a switch that is anomally high. Okay, means that switch ni sentiasa high. Okay, when you press, then it will give 0. Okay, write a program that toggle port C pin number 3 whenever the INT0 pin goes low. Okay, every time you trigger your interrupt, then the port C will toggle. Okay, so how to do that? Okay, first, lukis dulu lah. Okay, you're going to locate your circuit. Okay, so I'm going to lukis here. Okay, can you see my whiteboard? Semua boleh tengok tak whiteboard ni? Okay, so this is my Amiga 32. Okay, lukis dulu lah. Okay, so this is my PC3 and this is my. Okay, since you're going to use a INT0, okay, where I'm going to put my switch here? Dekat mana I'm going to put my switch? Where is the location of my INT0? Anyone? Okay, so INT0 is located at PD2. Okay, so make sure that at PD2, okay, you sambung lah you punya ni. Okay, so this is the switch. Okay, so this switch is normally high lah. Okay, when you press and then it will give 0. Okay, so now you're going to write the program. Okay, so mula-mula how to write a program? You have 3 steps. Okay, first you need to include the AVR / interrupt.h file. Okay, so now you're going to write the program here. So write a program. So in it, okay, include lah any file that you're going to include. Okay, so this is the first file that I'm going to include is avr /io.h. This is a standard. Okay, and then after that, I include this file here. Okay, so include avr /interrupt.h. Okay, next, after I include this file here, so what I'm going to do? Okay, so we just started with our main program lah. So int main void. So this is our main program. Open curly bracket and close curly bracket down here. Okay, what you're going to do inside of your main program? Apa yang kita nak buat? What are you going to do? Okay, you see here. Okay, you have a PD2 connected to switch and PC3 which is connected to, okay, this PC3, is it input or output? PC3. Okay, because PC3 here, the value will toggles whenever you press this switch. Okay, so it will become output. Okay, so what you're going to do is initialize your input and output port. Okay, so kita initialize dulu kita punya input and output port. Okay, so just write down lah. DDRC, even though I just use the PC3, so just write down DDRC equal to OXFF. Okay, tulis saja semua sekali sebagai output. What about the port D? Okay, DDRD equal to 0. Means that all of the port D here, I make it as a output port. Okay, and then since this is a switch, okay, next what you're going to do? Enable apa? Because port D here is connected to switch. So the next step that you're going to do, enable the, anyone? Every time you see your port is connected to switch, okay, so enable your pull up resistor. Okay, so how to enable pull up resistor? By sending 1 to your port. Okay, so since this is a port DDRD, so port D sama dengan OX. So this is how you're going to enable your pull up resistor. So this one here, this is a IO initialization. Okay, so kita dah initialize our input output port. Okay, next, what are you going to do? Okay, then after that, we go to our step 2 lah. Okay, what is your step 2? Okay, step 2 says that we need to enable, okay, your interrupt. Okay, there are 2 locations that you're going to enable your interrupt. One at your GICR, the second one here dekat SEI. Oh, not SEI, dekat status register. Okay, by using the SEI instruction. Okay, so just write down. Okay, so how to enable dekat GICR? So GICR equal to what value? Okay, so you need to recall back. Okay, so this is your GICR. Okay, we only focus on this 3-bit saja. Okay, we only focus on this 3-bit. So this is INT 1, this is INT 0, and this is INT 2. Since you're going to use the INT 0, so you put 1 lah kat sini, enables 1. What about the rest? You put 0. Okay, and so equal to 0B 0 1 0 0 0 0 0 0. Okay, this is how you're going to enable INT1. Oh, sorry, INT 0. Okay, that is a fancy way lah. Okay, to enable the INT 0. Okay, by writing something like this. Okay, so if you're going to write something like this, then your colleagues might call you are master in programming lah. Okay, GICR equal to, okay, put 1 to your INT 0. So this is another way lah, another fancy way. Okay, instead of using the traditional way, something like this, okay, you can put something like this. Okay, but I prefer this one. Okay, it depends on you lah, which one you're going to use. Okay, either way also correct. Okay, so you put 1, okay, put 1 to your INT 0. So the CPU know lah. Okay, you're going to letak satu dekat INT 0, which is this one here. Okay, means that you're going to what we call a shift 1 to a location INT 0. So that is mean this one here. The shift to the left 1 to the location of INT 0. So automatically INT 0 will get 1. Okay, then this one you already finished, and then you're going to enable your iFlag. So how to enable your iFlag? By using the by writing the SEI. So SEI. Okay, so this dah finish. Okay, step number 2, you already finished. Okay, next what you're going to do? Okay, so we use the while loop lah. Why while loop? Okay, since this is you're going to monitor this switch forever, so you put while 1 open curly bracket and close curly bracket. So you will keep monitoring. Okay, this switch here. Okay, when this switch is pressed, then it will go to your interrupt service routine. Okay, and then step number 3. What is step number 3? Okay, step number 3 is your ISR. Okay, write your interrupt service routine. Okay, so the interrupt service routine must be written outside your main program. Okay, make sure that the interrupt service routine is written outside your main program. So kita letak kat bawah ni ISR. So this is your interrupt service routine. Okay, and this one. Okay, this name here, the ISR name. Okay, make sure that the ISR name is correct according to the table I showed to you earlier. So this one here is INT0 underscore vector. Okay, and then open curly bracket, And next, close curly bracket. Okay, so you need to write down lah. Anything. Okay. The program for ISR inside here. Okay, so in this question here, okay, it says that the value of the port C pin number 3 will toggle every time you trigger the interrupt. Okay, so you can write down port C sama dengan, okay, port C, how to do a toggle. Macam mana nak buat toggle? Anyone? Okay, you can use the exclusive OR. Okay, so exclusive OR with 0B 0 0 0 0 and then 1 0 0 0. This is your PC3. Okay, this is exclusive OR. This is the symbol for exclusive OR. Okay, so the other fancy way to write this is port C sama dengan port C exclusive OR with put 1 to your PC3. Okay, is it? I don't know whether this is a correct way or not, ataupun you just 3 kat situ. Okay, means that shift 1 to the left 3 times. Okay, so this is the equivalent. Okay, and then you close the curly bracket. So this is the program. Okay, so the program will toggle every time you press your PD2 switch. You trigger your INT 0. Okay, any question up until here? Ada soalan tak? Okay, next week we will continue with with interrupt trigger. Either it's falling edge or rising edge. Okay, Lim Junji asking that ISR function will be called at which part of the program? Okay, still blur at this about this. Okay, so this one here, okay, the ISR will be called under here. Oh, okay, semasa while you doing the while loop. Okay, while 1. Okay, inside of this while 1 here, you just do nothing because there is nothing inside here. So you just waiting. Suddenly, okay, you press your PD2. PD2 is pressed. Okay, so once the PD2 is pressed, okay, while you waiting for inside of this while loop, okay, so what happened? Okay, so the CPU know that. So now the PD2 is pressed, so the CPU know that you're going to invoke, you're going to trigger INT 0. So that's why after that, okay, it will go to your here. You go to your ISR, your interrupt service routine for INT 0. Okay, so next it will do this thing until exit. Okay, so this is the RETI. Okay, this is your RETI. Actually, the close curly bracket here, this is your RETI. Okay, in the assembly language, we need to write the RETI to exit from the interrupt service routine. But for the C programming, the curly bracket here under the ISR is belong to your RETI actually. Okay, once finished, and then it will go to this while loop again lah. Keep looping. Okay, keep monitoring until you press the switch again. Okay, Lim Juji, am I answering your question? All right. So any other question? If no, then we continue next week. Okay, thank you, class. Okay, make sure that you sign the attendance. Yeah. For those who not sign attendance, please